Hi, hello, and welcome back to Rasa Chats, the Rasa podcast. And I am joined today, I'm very excited to tell y'all, by Xanda Schofield. Schofield. I don't know why I don't want there to be an E in there. And do you want to introduce yourself a little bit more?
Yeah, thanks so much for having me. I am an assistant professor at Harvey Mudd College right now. Harvey Mudd College is in Southern California, and it's a fairly small undergraduate-focused institution. So I spend a lot of my time teaching natural language processing as well as algorithms. And then in my own research, I look at natural language processing techniques for large bodies of text with relatively little structure, in that there isn't metadata that goes with the text. For lots of different applications, mainly focused on people who aren't domain experts in machine learning, and to find out ways that they can use machine learning to help answer questions about their text.
Yeah, I think that's particularly relevant to our community, because a lot of so Rasa, I'm sure the people who are listening often know about this, but just a quick review: we are in open source framework for building conversational AI, chatbots, if you will, and then we also have a series of tools for helping to develop and maintain and improve chatbots over time, particularly in an enterprise setting. And then we have a enterprise specific project called Rasa Enterprise, I think is what we've settled on right now, that's really focused on things you'd only need if you were working on a big team in a company. And as a result of this sort of team structure where a lot of people are working on the same assistant and they have, different backgrounds, different interests, there's quite a few people who are working on Rasa and working on assistants who don't have, a lot of machine learning background. And it would be great if you could just sort of talk about some of the things that people who are working with text and maybe are very familiar with, say, design principles might run into in this sort of more machine learning context.
Yeah, I think it's an awesome set of problems to think about, and a really subtle set of problems to think about. I should start by saying that, like, one of the things that's made me interested in the area I'm interested in, specifically helping people use machine learning tools for text mining, is actually that I started out as in my computer science career, not knowing anything about natural language processing or machine learning at all. When I was an undergraduate student, I was a computer science student, but I was like, I'm going to be a mathematical theorist. I'm going to study complexity theory. I didn't take a single AI, machine learning, or NLP course when I was a student. And then when I started thinking about maybe going to graduate school, at the time I was working on a search engine, and what I remember noticing was like, this is really hard, and hard for reasons that I didn't initially appreciate, about what it means to take language that you're getting from users without a lot of annotation about what users mean, and to make something of that. And I feel like that's a problem that's very much shared by all kinds of different applications, but especially chatbots, of just trying to make sense of intent. And that sometimes these questions that we think of as being something that we should be able to just quickly get an answer to start to become really complicated. Like when somebody when people say words, like, what is a word? Like, what is the part that you want to capture of people's text?
No comment.
Yeah, what is a word is one of those questions that you just get into so much trouble with. And until you've started to do text mining, you don't even know necessarily, I certainly didn't know when I started out, that was going to be a hard question. It didn't occur to me because it wasn't something I was thinking about, particularly as somebody who had really centered my experiences on the English language. I was often thinking about, well, you split things up by white space. A word is a thing that's what, sure, fine. And so what I've found when I've talked to researchers and practitioners who use text mining tools is they spend a lot of their time on these types of questions. Things like, okay, what are the actual words that people are saying? Or what vocabulary am I going to consider words? And there aren't always obvious answers to that. We have a lot of literature about, if you use this special model, you'll do 2% better at this particular kind of task, but not as much about like what it means to decide which words will or won't be included. And it can honestly take a lot of energy to just even chase down what it means to get a system that works well to do that.
Yeah, it's I would say if you really want to start like a bar fight at a linguistics conference, just like ask people to like throw down on what a word is. It is very contentious.
It's a joyful nightmare to ask people about that. like, what is a word? I actually even just recently had a conversation that I ended up starting on Twitter because I'm a little overactive on Twitter. And I had realized that in English, I was thinking about different letters and how often they're used in numbers in English. And I was thinking about like, well, what's the first like counting number that uses the letter A in English? And I realized like when I first did my count, I was like, it's 1,000, right? Like 1,000. Because 1,000 is the first sort of digit-related word that uses an A. This seemed like a really simple quantitative question when I asked it, even knowing what I know now, like as somebody who now works at NLP. At first, I was like, well, 1,000, and then I started talking to people, and they were like, 100, 101. Like they started pointing out that these connector words were actually had the letter A in them, and I went, oh, that's a good point. But I guess it depends on how you're communicating about it. I asked my dad, and he said not instead of 0, and I was like,
Oh yeah.
See, now there's synonyms, and this thing that I was thinking about as having a single way to express each number, that's not really true. So you get to this intersection of sort of like a standard logical process and how people actually talk, and all of the different unexpected things they say, and all of a sudden, all of the things that seem like reasonably scoped problems take time to figure out. And I think that's one of the things that we've been learning, particularly in the research I've been doing recently for tool development to sort of help with these kinds of technologies, is that it's really important to go look at the data and to go talk to people about how they're actually going to use these systems. And there's really no replacement for that if you have a particular domain that you're interested in, that using the sort of general understanding of what is going to be the best process to get your text out isn't necessarily going to work for your specific application or your specific question that you're trying to answer, your specific framework where you have different things that you're trying to fill in for a user in order to complete some sort of action.
Yeah, it's very hard because language is people, right?
Language is people.
People are not.
People are delightfully complex, consistently delightfully complex.
I was also thinking while you're talking about sort of like numbers, so there's a bunch of ideas about like the ways that people use language different depending on the context that they're using it. And one of those is sort of domains, so the general topic that you're talking about. And I was thinking about, well, in music, if you're counting with tempo, you'd be like, and a 1, and a 2. And where does that go? Is that a separate word? I would call it a prefix to the number. Yeah, it's really complex.
Yeah. And actually, it's funny you bring up prefixes in that sense, because like affixes are something that we spend so much time on when we're worrying about text, particularly when you're looking at a language, which is supposedly morphologically simple like English. And I admit I'm going back to English because it's where I've done a lot of work, but I want to say that there's much more complicated worlds out there. This is sort of starting with what should be easy, theoretically, what we supposedly invested the most time in already. But even then, like in some of my work that I've done in the past, when we look at word endings, there's a lot of sort of expertise that said, like, if you're doing these sorts of information extraction, information retrieval type tasks, or even if you're just, for the work that I often do where we use topic models, which are just bag of words models, which means that they're just counting the frequency of individual words, it might be worthwhile, is the common idea was, it might be worthwhile to combine words that are using different word beginnings or endings, but are otherwise the same root form. So like created and creative, or if you have a singular and a plural form, like ticket or tickets, that you're still thinking about the same thing. If somebody is looking to buy a ticket or buy multiple tickets, you want to sort of treat those as similar in terms of intent. And so there's often been people who will say, without a lot of detail, because it's usually sort of not the centerpiece of this work, will say, use some sort of tool, say a lemmatizer, which is something that will look up sort of the individual root forms, or a stemmer, which is a more fast and a little bit approximate tool to sort of remove word endings, that they'll suggest using this in order to capture that well. And one of the things that we discovered in our research is that it wasn't actually improving anything the way that had been advertised. That for the particular models we were using, actually the model worked just fine at figuring out that ticket and tickets were being used the same way. But in some of the applications we have, whether something is singular or plural makes a big difference. If you talk about Apple in a search engine, you're probably talking about a computer. If you talk about apples, unless you're fairly wealthy, you're probably not thinking about buying multiple computers. You're probably thinking about fruit. And that information was getting lost And it was getting lost because it looked like it was helping to do this process, but in fact, it wasn't really doing anything. And again, the way that you find this out, and the way that we found this out in our work, was starting to actually look at the text and figuring out what different things were and weren't being conflated when you take this kind of process in. So I think that it continues to come back to this lesson of like text and people are more complicated, and you have to grapple with that a little bit.
Yeah, and I think there's this big trend in NLP towards, if we just have more data, if we just have more compute, if we just have more parameters and we train it for longer, we'll get better results. So I think, the big neural language models, GPT, BERT, are sort of a very clear extension of that general stance towards working with language data. And there's a number of things there. But when you're working in say a very narrow domain, like a task-oriented dialogue assistant or a chatbot, like you might build with Rasa, dropping stuff on the keyboard. We always recommend that you as a developer, you start with like the skeleton of what you think people want to do. You start with very few things, and then as soon as possible you get it in front of people and you look at how they're actually trying to use your assistant and adjust your assistant and modify it and improve it to actually work with the way that people are using language, because it's not easy to predict.
Absolutely. Right. And it's interesting too that you bring up GPT and BERT as examples, because like one thing that comes up with language, like it is fairly common for people to say things that nobody has ever said before.
Yes.
Even when you're talking about something for a massive language model trained on billions and billions of words, like you and I are probably sometime today going to say a sentence that nobody has ever uttered in the history of the world, right? That's just a thing that actually happens fairly frequently. And so even if we tell ourselves, if we get enough data and it's learning enough about the structure, which we hope is what these models are doing, we're making assumptions about how people like develop new ideas in the world and change how they express things that just might not hold. Like the people keep shifting, and people are individual enough that we just continue to get these new ideas. So yeah, it's really challenging to deal with that. But then when you're also in a specific domain and you layer that on top, and it's, you no longer have lots of text, you no longer have, say, you can't assume that you have the average user as your average user for like the average user of the internet. That's not a thing that will exist for an application. That's not a thing that really exists in the internet in general. There's lots of different kinds of users, and you actually need to help all of them as opposed to some imaginary average. And so, yeah, and the only way you find that out is by looking at what users are actually doing, and not just looking at sort of people who are central to your user base, but also looking at edge cases. The same way that we would with debugging, the same way we would with anything else with design. You have to look at the edge cases.
Definitely. And I think that's we talked about with the sort of the edge user of the internet, quote unquote. One of the things that makes me excited about chatbots is, yes, if you have an excellent internet connection and, there's also a visual interface for what you can do and you're familiar with computers and you can just sort of breeze through, it might be quicker for you. But something that I think a conversational interface opens up is a lot of folks who otherwise wouldn't be able to do these things in an automated way, or wouldn't be able to like interact with a computer system as easily, either because they don't have data access, or it's very expensive, or it's just not supported in their language. So the idea that you're going to be able to get the wiki, a large data set for a specific user base just doesn't exist. And we've also, like you mentioned a lot, English. We get a lot of questions at Rasa because we're language agnostic, but out of the box, if you build your first model, it's going to be in English, which is, I would say, easy mode in NLP. There's a lot of people who are building assistants in languages with very few speakers, or that have a lot of speakers but not a lot of computationally readable data. Or if they have it, it's not structured, which is something that you've talked about. So maybe they have, a bunch of sort of like flat literary data files, and that's what you got. And also, like, the genre is not the same, so it sounds very fancy. And if you train your chatbot on that, it's going to be like, "Wherefore art there clouds today?" or that sort of thing.
Exactly. Yeah.
Yeah.
Yeah. It makes that adds so much additional like depth and detail when you're looking at like both a language which might not have the same sort of like codified resources that sometimes we run into in the sort of classic, like, let's say, academic paper version of the NLP world, where we can sort of look at certain reference data sets and we're really interested in models, and then we reuse these reference data sets a lot to sort of test those models. And that's not the world that most people live in when you're using NLP technologies. You've got your own individual users, you've got your own text that comes from that. It's smaller. Like we can still say big data because it fills up computers that no such computer was big enough, 20 years ago. But it's not that big compared to what a lot of models that, sort of set the state of the art in the academic world have. And we have to still be able to work with that. And it presents a whole separate set of challenges, particularly when within even that small group, there can be a lot of difference in behavior. Yeah.
And it's really an issue of, sort of like the highfalutin ideas of equity and fairness and access, but also very practical ideas of, if your chatbot is selling widgets and only 20% of the population of your town can actually use it, you're not gonna sell very many widgets,
Yeah, it's like there's a basic numbers thing there. There's additionally, like, if the goal of this is to help people who wouldn't use the standard interface you have for filling out a form, or would probably benefit from having an interface other than that because it will work more smoothly for them, then I would say that in particular in the environments that I've often found, like, my initial instinct at least is to start by saying, well, what's intuitive for me? And I am that user. And if we start with me, then it's not going to help. So at some level, we have to start talking about, and I admit this isn't my research area, this is something I've gotten more excited about recently as I've gotten more into the design world. We have to start with thinking about how NLP intersects with user-centered design. Like, how do we start with what users are doing? So if there's opportunities to, say, collect text or collect intentions from users for why they would want a chatbot from that group before you start, that might already save you a bunch of time later on.
Absolutely.
Oh, go ahead.
Yeah. Oh, I was just gonna say, a pretty common problem with a lot of the sort of traditional bot, not bun. I don't know. I'm trying to
spoken dialogue agent, text dialogue agent.
But a really common problem with a lot of sort of like early approaches to chatbot development is like, you're like, here's all the things my user will want to do, and you spend a lot of time investing in them and a lot of time sort of building up these systems, and then you have 9 intents and people only ever use 2 of them, and that's a lot of wasted engineering effort, and also probably not super satisfying to your users.
Absolutely. And you can spend a lot of time engineering for things that people just won't do, and you can spend in that process you also spend less time on the things that people really want to be smooth. Like, you add 2 extra clicks or 2 extra rounds of interaction for things that really are going to be the majority use case. And that's tough. And it's tough to know in advance which thing that's going to be, unless you talk to the users. I've been really delighted in a project that I'm working on recently. This is the first time that I've actually done like lots and lots of interviews as part of a project that I do, because historically I've been somebody who runs lots of experiments with existing corpora, does lots of standard evaluation metrics, makes up some new metrics, and then just puts tons and tons of tables and plots. Like, that's what I used to be when I was a software engineer. That's what I am now as a researcher. That's what I did in grad school. But one thing that we've been interested in is sort of taking some of the conclusions we got from those lots of plots over time and turning that into a tool that people can actually use. And what we decided to do, the specific goal of this is related to topic models, which is this unsupervised model of text, very different from chatbots, where we're sort of looking at what trends are in which words show up together to sort of try to capture what themes might show up in a large text collection. And in this type of model, one thing that can be really cool is if you're somebody who's working with sort of a smaller, medium-sized corpus instead of a really big one, you can still, without lots of additional sort of annotation on your part, get some information about what trends are in a larger text collection, which can be cool not only if you're somebody who maybe is doing some kind of content analysis for like surveys or something like that. But also like if you're a humanist or a social scientist and you're interested in or like a lawyer doing literature review, it might help start the search to figure out what some of the related terms are so that you can then do another layer of analysis after that. And so it can be a starting point for these sort of critical analyses that exist for large scale text collections, which is great, except that almost all of these tools were designed by and for people who are pretty computational. And more specifically, people who are used to looking at and thinking about evaluations meant for machine learning tools that are focused on evaluating the model instead of necessarily something about a text corpus. And I think that those evaluations, I love, I've run them lots, and they're a little misleading in terms of figuring out what's actually working or not. So that was a long digression. Right now, what we've been doing is we've been interviewing people who are mostly computational social scientists and digital humanists who have used topic models, and we're just asking them how they do what they do. And it has been amazing. I mean, I think it's been therapeutic for some folks because they get to say, like, it's been really hard. It's actually been really hard to do this thing. But and I'm also very lucky. I've had 3 different undergraduates who've been working with me doing the majority of these interviews, and they've been absolutely amazing at doing this. And these students, I should say their names, like Theobert de Bolo, Alfredo Gomez, and Tatsuki Kuze. They've been doing these interviews, and they've been both trying to capture sort of the broader sense of like, what tools did you use? How well did they work? What were you getting? What weren't you getting? And then also doing this more specific sort of cognitive task analysis of like, what are the decisions you're making and how are you making those decisions as you go through a particular project? And we've been able to break down something that I think, like, it seems like it's in a very different domain, but I think this is something that's shared with sort of chat interactions. We've been able to break down that there's a significant iterative process that happens that isn't really how we talk about using this type of tool in machine learning. Oftentimes, I think in machine learning, when we talk about like the machine learning side of NLP, when we talk about like training a model to do X and then evaluating the model to do X, it's like there's sort of stages, like the corpus exists. It's just like out of nothing, a corpus. And then you create this model and you tune it using this corpus, and then you have some held out data and you train on that. And the world is not that simple when you're really focused on the corpus instead of the model. Because you realize the first time you do this, because the corpus hasn't been used that much before, this text collection actually has some processing issues, and you're going to have to figure those out. You train the model and you see, oh, that's not what it's supposed to be getting out. And you go back and you look at the collection again and you say, these words are getting included and they shouldn't be getting included. And then you go try it again, and there's something else that's wrong. For like somebody who's working on literary text, the copyright notices are still intact. And you have to go get rid of those. And so you do this loop. Then you get to the point where the model's starting to work, but it's not quite capturing what you want. And you start doing loops with the model. And you might even go back and forth between cleaning up the data and working on the model. And this takes months and months for a lot of our researchers. And the fact that it takes months and months isn't a problem. The thing that's an issue is not knowing that that's what you're signing up for. And not knowing in advance that you're going to have to be ready for that kind of iteration, that you should be asking questions that support doing that iteration quickly, trying multiple things, experimenting with what processes are going to work. Because if you think it's going to be, we put the data into the model and we get out a result, you don't build the infrastructure to really get the information you need to make those decisions. So that's something that I think has been really amazing to hear from people, particularly the ways that they've ended up developing tools and pipelines to support that eventually. And unfortunately, the pain that sort of they went through in order to get to that point. And I think that that's something that all of us can learn from as a narrative, like the amount of work that it can take if you're not ready to iterate and to experiment, even when you think that you're doing something that's already prescribed, to get that outside information.
And then there's the emotional frustration of, oh, machine learning is so hyped and NLP is solved. NLP is not solved. I'm being facetious here. So what's wrong with me that this magic tool isn't working? I'm the dumb one. When that's not the case.
Yeah, absolutely.
And I think I was going to say this process. So you're talking about topic modeling, and I think there are actually some parallels in the chatbot development process, and particularly trying to figure out when people want to do something with your assistant that they can't do yet. So the sort of the way this process will often work is that you launch to a small set of users, and we we recommend an approach that's not really human in the loop, but a slower version of that, where you get your assistant's responses, you annotate them, you retrain, you annotate, you retrain, you maybe like combine some intents or separate intents, you add some entities, et cetera, et cetera. And a big sort of question there is, okay, adding an intent means I'm adding a class to a multi-class classification problem, which means that it is harder, which means I'm going to get worse results, just sort of like as the baseline. When is it worth it, right? When am I going to actually be answering a real need by doing this thing that's going to make it harder from a machine learning perspective? And it's not obvious, especially because there's this, I mean, the nice thing about chatbot sort of like returns is that you do have metadata about them. So it's not just like an enormous flat text file, but you sort of have to guess what the users are doing. And if you can do that by hand and it's a pretty small assistant, that's great. But like odds are, especially if it's in production, you're gonna have, you know, someone was asking me yesterday, they were getting like 20,000 interactions a day. That's a lot of data to look through by hand. How can you automate this process? So I think that this sort of like iterative process where you maybe you're using topic modeling. Oh, my internet connection is unstable. So hopefully you can still hear me okay.
I can hear you now. Yeah.
Okay, good. Fortunately, my audio is being recorded locally.
Yeah.
But this iterative process of like, okay, do I add a class here? What goes into this class? What's like the good canonical examples I should use as training data? What should I hold out for my test data? Is not simple. And often the people who are doing this, maybe they might have a really good background in machine learning, but maybe they might not.
Yeah. Yeah, and I think that like one of the things that I find myself saying the most, particularly outside of this research, when I've just sort of had informal communication with people who are interested in using topic models but novices, is like, if you know a lot about your users, that is expertise that is valuable for this process too.
Absolutely.
I think that there's a sense that somehow the magical algorithm is going to know more than us, but we as people know a lot about how people do things and have the ability to process what's going on with people in a way that, yeah, we're not close on in NLP. And I think there's some awesome research that talks about how not close we are at actually understanding things. Like we might generate text responses that are correct a lot of the time, but that doesn't necessarily come from models of understanding right now. And so trusting our ability to actually interpret, particularly, like I think that it's fantastic to have people who are not as machine learning oriented in this workflow, because I think that some of the basic questions that we might have of like, is this right? Does this actually make sense outside? Are easier to answer when you don't have as much experience or aren't as used to all of the quirky things these models do. Like I sometimes, I think, like sort of tune out the things that I expect to see. Like if a machine learning model is generating things, sometimes text generation has a tendency to do repetition or something like that. And I'm like, of course it'll do repetition, that's what it does. But my students are like, well, but why? And you know, I know technical answers to that, but like in terms of what the real thing is that we should do in response to that, that's, you know, sometimes I don't think about that when I really should be. And I think that there's a lot of value to actually being within that process of iteration, of thinking about what it means to really capture user intent, to decide what's going to be the most useful or least useful, and say, this isn't a machine learning question, this is a people question, and we should answer it using the processes we have to answer that. And yes, it does interact with this machine learning system, but that doesn't mean that machine learning is the solution to that. That we have so much other information that we can tap into to really do the best thing for users. So I'm rooting for everyone who's the like non-machine learning person working on this kind of technology. Like you know what's up. Trust that you know what's up.
Yeah, I think that's a really good empowering point to make. And I mean, chatbots are a great example of this, but does your chatbot work? Do your users think it works? That's really the core metric that you're looking for. And like all the blue scores or, you know, F1 scores in the world are not going to tell you that information.
Yeah, and I mean, I can think as a researcher, well, that's really good from a research perspective because we've historically been terrible and this is only somewhat bad, but that doesn't matter to a user. And
no, absolutely.
Yeah, when I say, well, topic models have this issue sometimes to people who are in digital humanities and been told that topic models are going to do this whole new thing, like, well, so what? Like, I'm trying to do this thing. I don't care whether that's the new state of the art or not. I just want to do my thing. And I think that it's worth valuing that sort of approach to things. Like, I also think we should be excited for when we do make progress on these problems. As a researcher, I'm always excited. But yeah, ultimately, it's going to come down to the user and what they're interested in, and what they think is actually working for them or not. And so that, I mean, as much as you can create evaluations that are around that or annotations that are capturing that, that's a good place to be from a design perspective. Yeah.
I would definitely agree with that. And I just want to pivot a little bit and talk about one of your other research interests, perhaps quite briefly, and that's text privacy. So I know a lot of our enterprise users are running into like GDPR stuff, and when do you have identifying information in like a chatbot turn, for example?
Yeah.
And I wonder if you'd sort of give a quick primer to somebody who's like in industry and they're like, I need to worry about this. What sort of things should I think about?
Yeah, that's a great question. So with respect to privacy, one of the things that's interesting is that privacy is a term that's thrown around to mean lots of different things. And in particular, one thing that I distinguish is when we talk about privacy, sometimes people really mean anonymity, which is just whether or not you can tell who somebody is when a particular interaction is happening. And that's often distinguished from privacy, where it's like whether you can even tell that they're doing this interaction at all. And so oftentimes what people are really excited about is sort of anonymizing users. Like, obviously you're going to have to interact with this user data and like perform actions and things like that, reserve tickets on a plane or something. Like, a thing will happen, right, in the world. Some sort of transaction will be made. And so those events are going to get stored somewhere with some metadata information. And when you're thinking about privacy, like, protecting that data is something that is eventually going to become important no matter what, in a separate way. But when you're talking about dialogue as well, something that makes things challenging is, in addition to what we would describe as personally identifying information, which is things like, you know, somebody's address and their full name and their date of birth and things like that, that there are pieces of information that you wouldn't think are individually identifying, but if you get enough of them, can be identifying as well, particularly when you also have some sort of external source for data, which in most countries exists, that there are public records, or companies might have, or somebody might have a social media account or something like that. But there are all sorts of other external resources that can be used in adversarial ways in combination with a lot less data than you would think in order to figure out who somebody is. And I think that this is something that can make sort of anonymizing data from chat logs particularly difficult, because even when somebody in a given chat interaction turn isn't necessarily sharing any entities that would match sort of like the regular expression for, like, this is something that needs to be kept private, this is a credit card number, something like that. If they say enough things together, that might still be enough to identify them. As an example that is sort of referring to personally identifying information, but like a very commonly cited research example is LaTanya Sweeney's research in privacy, where she found that, I think it's Washington State data that she was using, but she found that most people you could identify uniquely using their gender, their zip code, and their date of birth. All of which, like, together, those are things that oftentimes we would consider private information. If we had them in a database, we wouldn't want people to just be getting them at random. But those three pieces on their own, being an individual identifier, is a little bit surprising initially when you think about it. And you can do the math and realize why this is the case. But a zip code should, you know, like, have thousands and thousands of people in it. And gender, assuming you're dealing with a government form, which is often binarized, then you don't have, like, most people are going to fall into two options that are on the usual government menu, and then date of birth is somewhat unique, but it's like, it doesn't seem like initially, if you were just asking somebody for the date of birth, that wouldn't be an issue necessarily, right? There's lots of people with the same birthday, but you take them together and it's a problem. So that all, talking about privacy as sort of an initial introduction, that all comes up, right? So we have to think about the fact that it's not just every single individual piece of information, whether it should be private or not, like a social security number should be private. Its combinations can also be a big problem if you're trying to protect the identity of who's using your system. And then when you get into NLP, everything gets even weirder, because there are types of things that people will say that, again, people say unique things all the time, right? There are types of things that people will say that will uniquely identify who they are. If you have somebody who's, interacting with a health application and they say enough about what they're doing or what they're interacting with and things like that, you probably can place where they are and when this is happening and things like that. And so oftentimes the approach to privacy is to basically try to take out enough information to make it so that it is very hard to basically recognize any feature as being individually identifying. So that's often been the approach. I think it's an aggressive approach for a lot of systems, but that has often been the approach that the community has fallen to, because it's just really hard to pick a subset of features of text that is going to be sufficient to truly know if you've actually made it so that somebody won't be identifiable. Because people say things that are very specific to them, and it doesn't take as much searching online as you would think to be able to find that person.
Or even something like the combinations of emoji that you use. So that information is, if you're using like a smart keyboard on a phone, for example, going to be stored. And there was, like a meme fun thing going around where people were like, your top 6 most frequently used emoji are your aesthetic. Well, if I had that information for somebody, I could probably link to their accounts across social media platforms, even if I didn't have, their account name or they hadn't linked it, because that's pretty identifying.
Absolutely. And you wonder, like, if you were somebody who had a predictive, like, had access to the predictive text models, and actually differential privacy, or just sort of this research area of how do you add randomization to different sort of algorithmic processes to make sure that it's difficult to recover what the original data looked like or which entities were in the data. Both, I think, Apple and Google, and I think a bunch of other companies too, but those are the 2 examples that come to mind, for their predictive text use differential privacy, and they use local differential privacy, which means that they're adding randomness basically at somebody's phone when they try to learn from that text data, to try to make sure that that you can't actually predict, because people say things so uniquely, that you couldn't use the predictive text model for some individual to figure out who that individual was. Because if you did have access to everybody's individual phone keyboard predictive text, because it does personalize for all of us, then you would be able to figure out from one of those memes online of like, finish this sentence, you'd be able to figure out who they are. And similarly, like, and this relates to the sort of personally identifying information of somebody can say, like, your new band name is based on the month and date of birth for somebody who's on Twitter, and at which point their gender and maybe the town that they're from are already available, and we get to the individually identifying and able to look up on public records immediately, right? And so it's like these little things about language use can actually be very distinguishing. So that's why I think, like, within the research that I've done, I'm part of a group of researchers where our approach is randomize everything. Like, we just don't know which features are going to signify. And the way that you figure out how much randomness to introduce is going to be based upon how much that particular word varies in usage between users. And then the trick is really figuring out how to calibrate that.
Yeah, it's definitely a hard problem.
It's really hard. And it's something where I wonder, because the differential privacy is sort of the hot approach to this. It's this adding randomization. You can sort of prove, like, the probability of getting this thing out that your model gave out isn't that much bigger with a particular record in as with a particular record out. So whether a user is present or absent, or whether a document is present or absent in the data training, you're making guarantees based upon the statistical probability of generating an output plus or minus an individual record. And this framework is very popular because you do get this sort of like nice proof feeling thing about like what the guarantee actually is in terms of probabilities. But the way that this is parameterized is still kind of hard to map to the real world, because the way that you decide what the right probability is for your data to be secure enough isn't super well specified. If you talk to differential privacy researchers, they'll usually laugh about this as they talk about it, because there's a particular variable that people will use to sort of calibrate that probability called your privacy budget. It is epsilon if you're into the Greek. And people will say, like, how do you set epsilon? And you ask your researcher this and they'll say, 2. Two should work. Use two. And then you say, okay, but I'm working on text, so I have this many features. I need to set it for all of the features. What should I do? Like, oh, smaller. And you run into that problem where it's like we have a rough sense of where it seems like from a particular application things will work well. But mapping those theoretical parameters onto the real world is a real challenge still. And I think it's something that people are actively working on and thinking about how to communicate about better from the privacy community. But it does make it a little bit hard to initially figure things out, particularly because those guarantees aren't necessarily going to make sense to a user in terms of what it means that they have a privacy budget of epsilon set for themselves. Like what does that guarantee for them? And so if it's possible to come up with ways to describe, even for simpler things like just censoring out particular data or randomly throwing away some records or things like that, like, hey, we think we can guarantee to you this fact, that's often a lot easier to communicate to a user. And it's worth thinking about like what kinds of guarantees people are actually looking for and how to implement that in a way that is interpretable. Not to be rude about differential privacy. I think it is amazing, and I'm so excited the level of adoption it's getting. It's like being used in the census and things like that now. But
throwing a bunch of Greek letters at somebody and being like, "Is this good?
Yeah,
you like this?" Like they're not going to be able to make a very informed decision.
Yeah. I set a bunch of parameters you don't know about in a way that I think makes you safe. Do you feel safe now? That's not how the world works. I mean, any more than when I talk to my topic modeling researchers and I say, oh yeah, so you have to use asymmetric hyperparameters is a thing to help set up models better sometimes. And I say that and they're like, cool, what is that?
What does that mean for me?
Why do I care? And it's like, well, and even if it does require a little bit of an oversimplification, as long as you're not being dishonest about what it's doing, it's important to be able to communicate about what that actually does. So if I can say, effectively, while it's not directly this is a simplification. When I say use asymmetric hyperparameters, what I mean is you're trying to find different patterns of words that show up together. And some of those groups of words are going to show up more often than other groups of words. So you should let the model know that it can let those be different sizes. That's what I want to, like, that's what they actually functionally can work with. It's an oversimplification, but functionally that's what is happening. And so the more that you can find the way to communicate about that and understand that, particularly this is for the people who would be more on the technical side, the better value you're going to get out of providing that sort of privacy guarantee.
Yeah, it's a lot of hard problems.
Yeah.
Right, well, before we wrap up, I just want to give you a chance if you have anything that you want to plug or anything that people should know about, or I don't think Harvey Mudd has grad students, so people can't go to grad school and work with you.
Well, yeah, so I will say that like I work at Harvey Mudd College and I think Harvey Mudd College is awesome. And we have a bunch of other researchers working on amazing things on top of doing all of this teaching, and we have amazing students. So shout out for my school, because I think it's one that often it's pretty small and people haven't necessarily heard of it. But separately from that, one of the things that I'm currently working on is the sort of topic modeling tool. So while I don't have something to like release just yet, if there's anybody who's interested in learning more about these tools, you can find me on Twitter at Xanda Schofield, so the way that my name is written out. And I'd love to talk to you about these things, particularly if you're interested in sort of social science applications of text mining. We're trying to learn more about how to make this work for novices, and I'd love your input. So I'd be really excited to hear from folks.
That's it. Great. I hope you get some good participants is what I was looking for. Wow.
Yeah, we'll see on participants, because coming soon, hopefully. We're working on getting our user study together now because we're starting to get the software together. I'm very excited. So we'll see.
I think my dog is telling me it's time to wrap up.
Oh, I see.
That's what that sound was. Thank you so much for joining me today. Yeah. This was a really great conversation. I definitely enjoyed it. I think it'll be really helpful for all of our users, and maybe open up some areas of inquiry that might be helpful for them. Yeah, and I'll talk to you later.
Thanks. It's great to talk to you, Rachel. Thanks all.
Thank you so much for joining us today for Rasa Chats, our podcast. And I want to take a quick second and shout out our new Rasa contributors. As you may know, Rasa is an open source project, and we really value all of our contributors and community members, and I want to take a moment here to thank people who have made a contribution to Rasa for the first time. So for their support contributions, Miriam Khurshid Hamed, Arka Prabha Mujamdar, Mad Shurkri, and Shivam Dutt Sharma. Thank you all very, very much for helping the Rasa community. And for their code contributions, Imain Araf, Duckmin Fan, and Or Shailon. Thank you so much. Fantastic work. We are delighted to have you as part of the Rasa contributor community. And as always, if I mispronounced your name, I'm extremely sorry. Reach out to me and I will correct it the next time I record a Rasa Chats podcast. Thanks so much for joining today, everyone. I hope you found this informative and fun, and we will see you next time on Rasa Chats. Bye!